Hello learners. In our previous lesson, lesson 4, we were dealing with the amphoteric oxides and hydroxides. In our lesson 5, we are dealing with the salts. So let's start. What is a salt? A salt is an ionic compound formed when a cation derived from a base combines with an ion derived from an acid. Remember, we were having in Form 2 a chapter called salts. We were defining salt there, and we say salt is any substance that's formed when the hydrogen ion in the acid are wholly or partially replaced by a positive ion. But we are in Form 4 now. We are defining a salt in another way. A salt is an ionic compound formed when a cation, that's a positively charged ion, derived from a base combines with an ion, that's negatively charged ion, derived from an acid. Examples of salts include lead 2 chloride, or you can have there lead 2 nitrate. We have zinc sulfate, we have sodium chloride, we have calcium chloride. So let's just try to have maybe a salt that's, we are dealing with maybe lead 2 nitrate. So if we have in lead 2 nitrate is written like this. Lead 2 nitrate is an ionic compound. It's an ionic compound because it's having lead, which is a positively charged cation, and also nitrate ions, which are negatively charged anions. So salt is an ionic compound that's formed when a cation, that's the positively charged ion from a base, combines with an ion derived from an acid to form that salt. Examples include lead 2 nitrate, zinc sulfate, sodium chloride, and also calcium carbonate. Okay, let's go to precipitation reactions. So even in Form 2, we were dealing with precipitation reactions when we were preparing insoluble salts. So precipitation reaction is a chemical reaction which involves two salt solutions in which two different metal ions exchange acid radicals to form an insoluble salt and also a soluble salt. Even back in Form 2, we said precipitation reaction, the condition is you are supposed to have two soluble salts, and the product formed, one of them will be insoluble salt and the other one will be a soluble salt. On top of that one, we said the insoluble salt is called a precipitate. So what is a precipitate? A precipitate is an insoluble solid that separates out from a solution during chemical reaction. So if you are told what's a precipitate, you know. Let's get examples. Examples include, if you're having sodium sulfate reacting with lead 2 nitrate, check both these two are soluble salts. Go back to the solubility of salts. We're having all sulfates are soluble except lead, barium, and also calcium. But this is sodium sulfate, or you can say all sodium salts are soluble. That means we're having a soluble salt of sodium sulfate and also lead 2 nitrate, because we said all nitrates are soluble. So the product that you're going to get, lead 2 sulfate, is insoluble because we said all sulfates are soluble except lead. Okay, sodium nitrates are soluble because all nitrates are soluble, or all sodium compounds are soluble. So we can write this in a chemical equation. We're having sodium sulfate. Sodium sulfate, which is aqueous, reacting with lead 2 nitrate, which is also aqueous because it's a soluble salt. So when they react, what are they going to do? That means the ions, the cations, are going to just exchange with the anions. So that means sodium ion will get the nitrate ion. Then this lead 2 ion will get this sulfate ion. So we are going to get the lead 2 sulfate, which is solid, plus sodium nitrate. So to balance the equation, we are supposed to put 2 here. So that is a balanced chemical equation. So for us to write now the ionic equation for this reaction, remember we are supposed to remove the spectator ions. So here we are going to get lead 2 ions plus sulfate ions, which is aqueous. Thereafter, we are going to get lead 2 sulfate, which is our precipitate. So that is the ionic equation that results to the formation of the precipitate. That is the lead 2 sulfate. Next example, we're having zinc chloride. We do the same. Zinc chloride is a soluble salt, aqueous, because all chlorides are soluble except lead and silver. And here we're having silver sulfate. All sulfates are soluble except lead, barium, and also calcium. we are going to get silver chloride. So we are writing silver chloride. Silver chloride is solid, and we are going to get zinc sulfate. Remember, we said all chlorides are soluble except lead and silver. That means silver chloride is a precipitate. So to write the ionic equation, we are going to have silver ion, which is aqueous, reacting with chloride ion, which is aqueous, to give you silver chloride, which is solid. That will be our ionic equation. Okay, next we have complex ion. So you can be told, what is a complex ion? Complex ion is an ion consisting of a central metal ion surrounded and linked to a number of neutral molecules or negative ions. Okay, thereafter we are saying the hydroxides of zinc, aluminum, lead with excess sodium hydroxide form soluble complex ions. Examples. We are going to see the examples. So the first example, we are having zinc 2 ions reacting with hydroxyl ions, giving you zinc hydroxide. Remember, zinc hydroxide is a base, and we said bases are categorized into three. We are having soluble bases called alkali. Those are group 1 hydroxides and oxides. Next, we were having slightly soluble bases. Those are group 2 hydroxides. Then we are dealing with the rest, which were insoluble bases. So if you are having maybe zinc sulfate, you are having maybe zinc sulfate. Remember, zinc sulfate is a soluble salt. So here is a solution containing zinc 2 ions. Then you have reacted with sodium hydroxide. You have reacted with sodium hydroxide solution. So that means the reaction that's going to happen there will be, we are going to get zinc hydroxide and also sodium sulfate. So remember, zinc hydroxide is insoluble base. So we are just writing the ionic equation to remove that spectator ions, like that of sulfate ions and also sodium ions. They are just spectator ions. So we are having zinc 2 ions reacting with 2 mole of hydroxyl ions, giving you 1 mole of zinc hydroxide, which is a precipitate. So the color of the precipitate that you are seeing will be a white precipitate. That BBT, it's a precipitate. So next, what will happen if that precipitate we add again excess sodium hydroxide or more sodium hydroxide solution? So that means the zinc hydroxide solution, solid, will, that's the precipitate. The white precipitate is going to dissolve, because we are having here aqueous. It's going to dissolve to form now zincate ions. So this one is called zincate ions. Okay. So what is the color of this zincate ion? It is colorless solution. It is a colorless solution, and it's a complex ion. So next, we can have aluminum ion reacting with hydroxyl ions, giving you aluminum hydroxide. It's a solid. It's a precipitate. Still, it's a white precipitate, white PPT. So if you're having that white precipitate and you add excess sodium hydroxide, that means we are going to get aluminate ions. So these aluminate ions will be colorless. It will be colorless ions. They are colorless. Then next, we can have lead reacting with the hydroxyl ions, lead 2 ions reacting with the hydroxyl ions, giving you lead hydroxide. So this is still a white precipitate, white PPT. Then if that white PPT, you add excess sodium hydroxide or more drops of sodium hydroxide, the white precipitate dissolves to form a colorless solution. So this colorless solution is called Blombate ions. Blombate ions. Okay. Thereafter, let's go to the hydroxides. The hydroxides of zinc and copper reacts with excess ammonia solution to form soluble complex ion again. Example. So here we are having zinc 2 ions reacting with ammonia solution or aqueous ammonia or ammonium hydroxide, giving you zinc hydroxide. So zinc hydroxide is a precipitate. Still, the color that you're expecting there is just a white precipitate. So that white precipitate, which is zinc hydroxide, will still react with more aqueous ammonia to form zinc. It's called tetraamine. Tetraamine zinc 2 ions. Tetraamine zinc 2 ions and also hydroxide ions. We are having 2 of hydroxide ions. So come to copper. Copper 2 ions will react with that hydroxide ions to give you copper 2 hydroxide. This is a precipitate, but the color of the precipitate in this, it will be a blue precipitate. So if you take that blue precipitate and you add excess aqueous ammonia or ammonia solution, we are going to get tetraamine cobalt-2 ions, cobalt-2 ions, and also hydroxyl ions. So what is the color of this tetraamine cobalt-2 ions? It will be deep blue in color. The color will be deep blue. So during the exam, how are you going to know how to write this complex ion? For example, you are supposed to know the one for lead and also zinc, they are the same, because zinc and lead are having the same valency, which is a valence of 2. So they are going to have with the same formula. They are going to have the same formula. So how are you going to know if, again, your complex ion is correct or not? So you know it's written something like this. So this one, instead of you saying zincate ion, you can say hydroxo zinc 2 ions. You can also say like that, zinc 2 ions. So check if you want to know now the judge. That means what you are supposed to have here as your judge. You just do or add the oxidation number of what you have here, this ion. So zinc, we know, is a metal. We are going to have ballast 2. That's the oxidation number of zinc, ballast. So here you're having 4, you write 4 in bracket. So here, what do you have? You have oxygen. So what is the oxidation number of oxygen? -2. Ballast, what about hydrogen? +1. So here, what are you going to get? Here, you are going to get -2 + 1, that's -1. So -1 times 4, that's -4. +2, you are going to get -2. So that means you are going to put there 2- as your judge. You get it right? Here we are having 2-. The way you did this, you can do it in aluminum. You will get -1 the same. You can try that one on your own. Okay, come to this side, this other side. Okay, here you are having something like tetraamine zinc 2 ions. Remember again, zinc and the copper that you have in tetraamine cobalt-2 ions, they're having the same valency. So you're expected to write the same thing. If you know how to write one complex ion, you know the others now. Okay, let's check. We are having zinc 4. Okay, if I want to get what I have here, what I'm going to say is I'm going to write the oxidation number of this zinc. Zinc is +2 ballast. So we're having here 4. But this ammonia gas is a compound. So its oxidation number, full oxidation number is 0. So 0 times 4, that's 0. So ballast 0, that means you're going to get ballast 2. So that means what you're supposed to write up there is ballast 2. So when you're writing the one for ammonia, it's ballast 2. But when you're writing sodium hydroxide, it's -2. You have to know that. Okay, lastly, in B, you are supposed to note this. Note this, only zinc hydroxide dissolves in excess of both sodium hydroxide and also ammonia solution. So when that zinc hydroxide dissolves in sodium hydroxide, we are going to get that thing called tetrahydroxo zinc 2 ions. When it's dissolving with ammonia solution, we are going to say again tetraamine zinc 2 ions. So after that,